Hey guys, today's learning objective is an introduction to sequences. This is very much a theory-based lesson. We'll talk about what sequences are and kind of just give you an overview to some of the notation that we need to use that's quite important. So there's not going to be too many kind of worked examples. They're going to be right there. They're going to be quite short. So as usual, this is going to be a timestamp series. So feel free to skip to any part of the video. But yeah, let's get into it. So first thing, what are sequences? So sequences are just kind of an ordered list of numbers, and they can be kind of finite, something like 1, 5, 9, 13, for example. So there's only 4 terms here, or they can continue on to infinity. So if we had something like 1, 8, 15, 22, and just continuing forever and ever. So we have, as I said, finite and infinite. And basically, when you say an ordered list of numbers, it basically means that there's some sort of relationship between the numbers, as you can see, for example, in this one. In this case, you add 4 to get to the next term, so this is an example, or here you add 7 to get to the next term. So that's kind of what we mean by it's an ordered list of numbers. There's some kind of method behind the madness. There's some kind of logic to kind of why these numbers come together. It's not just say kind of a random list of numbers. If I just say 1, 7, 8, 3, or whatever, kind of just make up loads of numbers. There's something behind this. That's kind of the big difference. So we have kind of this notation. So the first kind of term we say is something a subscript 1, and the second term we say is a subscript 2, and then same with 3. And same with 4. It's a subscript 4. And kind of a general term, so you don't necessarily know what position it's in. You could say it's a subscript n. So say that's the kind of the nth term in the sequence. So this is the first term, the second term, third term, fourth term. Of course, this is only a 4-term sequence, right? So if I was to say if I was to say a3, I'm referring to the third third term in the sequence. Sorry. So that's kind of that's the notation we have in general, so kind of referring to it. So in an infinite series, if I was to say what's a to the n, well, that'd just be kind of the nth term. That's all this is saying. This means the nth term in the sequence. And now that we have kind of this way of kind of these terms, we can see, for example, in this sequence, right? We can see that we add 4 to get to the next term. So we can kind of say that, A2 is A1 plus 4, and A3 is A2 plus 4, right? So, 5 plus 4 is 9. And same with A4. A4 is A3 plus 4. And this is kind of a term-to-term rule. It shows us saying how one term, A1, is related to the next term, A2, for example. So if you want to go from A1 to A2, you add 4. And since kind of this pattern actually holds for all the numbers, well, we have a kind of a general thing. We say, for example, AK is equal to AK plus 4. So, sorry, AK minus 1. So AK is the kth term, and it's kind of like the general term we're saying, is equal to the term that's behind it plus 4. So for example, if we look at here, we say, look, A4 is so the K would, if K was 4, A4 is equal to A3 plus 4. And it's the same logic for each of these. So this is how we have this is what we call a term-to-term rule. Because it shows us how 2 terms are related to or how one term is related to the next. And this holds for all the terms, right? So that's kind of, it holds forever. But also, we know AK is that, right? This is how we know it from one term to another. But how do we know what the first term is? The first term, if the first term was say 5, right, or not, say 7, for example, then we'd have a kind of a different pattern to this one. So you can see why you need to specify what the first term is. So you say AK, so you have this term-to-term rule, but you also specify what A1 is. So you say A1 is 1. But if, for example, if we had A1 as say 2, we'd have a completely different sequence to this. We'd have 2, 6, 10, 14, which is obviously different to this. If we look here, for example, what's the term-to-term rule here? Well, we can see kind of the next term on is the previous term plus 7, and that's kind of that holds throughout. So in this case, we can say AK is equal to AK minus 1. So this term, the term I currently have, is equal to the term minus 1, so the term before it, plus 7. And you can see that holds, right? So for example, this is A3, right? This is A4. A4 is equal to A4 minus 1, which is A3 plus 7. So again, and we have to specify what the first term is. A1 is 1. And again, this is what we call position to term rule. Sorry, a term to term rule. The next thing we're going to talk about is a position to term rule. And that's kind of saying we know what the position of this is. So I say this is the fourth term, right? Fourth term. Is there a way from just knowing it's the fourth term to know kind of what the number is exactly? And so you kind of have to think, what's the relationship between, so this is, what's the relationship between 1 and 1, 2 and 8, 15 and 3, and 4 and 22. And I'll show you how you figure this out in the next not in a few videos time. But for example, here the position to term rule would be AK. Well, let's say AK is equal to 1 plus 7k minus 1. And you can verify this, so you can say, A1 is equal to 1 plus 7 times by 1 minus 1, so 7 times 0, which is just 1. Let's try A3. A3 is equal to 1 plus 7 times by 3 minus 1, which is equal to 1 plus 7 times 2, which is 14 plus 50, 14 plus 1, which is 15. And you can kind of see how that works with 22 as well. Whereas here, you'd have the position to term rule of AK is equal to 1 plus 3k minus 1. And again, you can verify this. If you want to pause the video, go ahead and verify it. And so this is what we call position to term rule, because all we need to know is the position the term is in, and we can see what the value of it is. Whereas here, we need to know the the value of the number before it in order to calculate what AK is. So that's kind of the two differences. What you need to also be able to do is if you see a position to term rule, for example, like AK is equal, term to term rule, AK is AK minus 1 plus, let's say 12, and I ask you to generate the first 4 terms, you should be able to do that. Let's say A1 is, 3. So, if you pause the video and I ask you to generate the first 4 terms, you can just go ahead and do that. Okay, so we know the first term is 3. That's given to us right here, thanks to that. So we say 3. Well, A2 is equal to A. So this rule applies for all k, all values of k, right? So A2 is equal to A2 minus 1 plus 12, which is A2 is equal to A1 plus 12. And we know A1 is 3 actually, so 3 plus 12, which is 15. And then A3 is equal to A3 minus 1, which is A2 plus 12. And again, we know what A2 is, it's 15, so 15 plus 12. So we have 15 plus 12, which is 27. And you can see how the next one will just be 27 plus 12, which is 39. And that's the first 4 terms done. And that's how you generate the first 4 terms with the term to term rule. If you're also with a position to term rule, if you have, for example, something like AK is equal to 4 plus, 4 again, k minus 1. And you're also generating the first 4 terms. In this, it's almost easier than the previous one, because you can just plug in whatever value you want for k. So if you want the 7th term, for example, you just plug in 7 where the k is, and you can find what A7 is equal to. So A7 is, for example, 4 plus 4 times by 7 minus 1, which is 4 plus 4 times 6, which is 4 plus 24, which is 28. So for example, if you were asked to calculate what the 7th term is, you just plug in 7 where k is, and that's how you do it. Or if you whatever term. But in this case, let's say I ask you to generate the first 4 terms. So you stick in 1 where the k is. So A1 is equal to 4 plus 4, 1 minus 1, which is just 4. So 1 minus 1 is 0. So 4 plus 0, which is just 4. A2 is equal to 4 plus 4, 2 minus 1, which is 4 plus 4 times 2 minus 1, which is 2 minus 1 is 1. So 4 plus 4, 8. A3 is equal to 4 plus 4, 3 minus 1, which is equal to 12. and A4 is equal to 4 plus 4, 4 minus 4, so 4 minus 1, sorry, which is equal to 60. So that's the first 4 terms generated. So kind of we've talked about a bit about what sequences are. So it's, remember, an ordered list of numbers. An ordered list of numbers. Yeah, ordered list of numbers. That's the definition. And kind of there's two ways we have of kind of describing what they are. So we have a term-to-term rule. And this requires you to know what the previous term is, or at least one. Sometimes you actually need to know what the previous 2 terms, the previous 3 terms are. But you have to know what the previous at least 1 term is to be able to kind of figure out what the next term is. Where a position-to-term rule, you only need to know what the position of the term you're looking for is. So in that sense, kind of, this is almost a broader definition in some sense, kind of sometimes a quicker one. But they both have their uses. But yeah, hopefully that all made sense, and I'll see you guys in the next.